Okay. So, shall we start?
Yeah.
Okay. So, my name is Anubhav. I'm from SKIT, a final student in computer science engineering. So, how many of you know programming over here? At least basic if else logics. Okay, great. At least everyone knows it. Okay. So, suppose that if you want to make a self-driving car, how would you make it using just the if else conditions? Or what do you think how it can be? Would it be something like this? If a person is in front of the car, action should be stop, don't crash him. But what if there is a dog or a cow in front of the car? Obviously, we have to write if else conditions for that as well, isn't it? But no matter how many if else conditions you write, there will always be some conditions which you will miss out, and we can't make it, right? So this is where we have problems, and there are many such applications in our real world right now, such as self-driving cars, speech recognition, which is in our phones, which are using such things in which there are various, various ways of saying it or various ways of doing it. So what is the solution for that? The solution is machine learning. In the next 20 minutes, we are going to discuss what is machine learning, why is it so popular right now, some of its application and algorithms, and also we will see two of the projects that I made on machine learning in the recent past. So let's get started. So, what is machine learning? As the definition says, machine learning is a study of algorithms that improve their performance at some task with experience. It means understanding through data. Now, in the current scenario, data is very cheap and abundant. On Facebook, if we are there, we have our images, all that data online. But knowledge is expensive. Knowledge is what it is. Knowledge is which is valuable. In 1959, Arthur Samuel said, "It gives computers the ability to learn without being explicitly programmed." That's what's machine learning. So, if it was in 1959 that Sir Arthur Samuel said these things about machine learning, why is it now that it is growing so fast? Why wasn't the self-driving car made in 1959 or in 1940s when machine learning actually started? Basically, there are two main ingredients for the magic recipe. The first is large data sets. Everybody might have known about Moore's law. So basically, our data in the current scenario is growing exponentially, and we have terabytes of data, petabytes of data online. All this data makes it possible to use machine learning algorithms on it. Because machine learning is all about training and learning through the data. So the more data we have, the better it will get. The second is powerful, fast, cheap computers. Because in the later times, we had these big, large labs which had computers with very small computing power. But right now, we have laptops in our table which can process much more data, 100 times data more faster than those computers in that time. So that's why we have improved with machine learning so a lot, because all these data crunching tasks require high computation power, which we have in our hands right now. So let's go and see some of the applications and algorithms of machine learning. The first is learning associations. So machine learning is very good algorithm for learning associations. So like for example, in the morning when you go to buy milk, it is highly probable that you might go and buy bread also with it, right? So like this is the market basket which we have right now, and there is the probability that if we are buying bread, then the probability of buying milk is 0.7. That is out of 1 to 0. Okay. So where it is used right now, it's used by companies such as Amazon, Flipkart. Everybody has used it, right? So whenever we buy something, it also tells us in the recommended section that you might also like to buy these things. Whenever I'm going to buy a laptop, they might tell me that you might also like to buy a mouse or something like that. So all these things are done using the machine learning algorithms. It learns the association using the data which they had previously. Like if I bought a laptop, I bought a mouse with it as well. So from the next time, it will suggest me that alright, you have bought the mouse, you might also like to buy a mouse pad. Okay. So that's one application. The next application is classifying or logistic regression. So basically, in this example, what we have over here is classifying the different type of cancer tumors. One is malignant and benign. So there are some features like size of the tumor and what is the position where it is and all that stuff. So what we do is we feed all that data into the machine learning algorithm and we tell it that alright, if the size is so and so, the cancer is basically malignant, or if the size is so and so, it is benign. So the machine learning algorithm makes a linear line over it, a differentiating line. Basically, it is mathematics, pure mathematics. Y equals to mx plus c. So we are giving x as the tumor size, and so we are able to classify where all the malignant are and where all the benign are. And other than that, we also have applications such as spam filtering. Whenever we go in our Gmail, Google account, so we see that all the bulk emails in the spam, those are classified automatically. So that is done using machine learning as well. It sees that the people are deleting those emails frequently, so it learns that these kind of emails might be spam. It also reads the email's content and classifies it whether it is a spam or not. Another very popular aspect of it is unsupervised learning. So right now, whatever we were doing, like we had malignant and benign, those were the labels with the data set. If the size of the tumor is this, we were telling the machine first that this is malignant or benign. Similarly, for spams, we were having the content of the email and we were saying whether it is a spam or not. In unsupervised learning, we don't have these labels. We don't tell the machine what it is. We just feed in the data and we tell the machine to classify what it sees from the data. So for example, if I gave the raw data of some shapes in it like triangles, rectangles, whatever, it will apply the machine learning algorithm and classify different according to the edges or maybe some patterns which it sees. So we didn't tell it to classify all these groups into these groups, but it automatically did it by finding out the pattern. So there are some of the algorithms such as k-means and mean shift which is used in this. So the next popular algorithm which you might also be interested in is reinforcement learning. So it has been right now used in many applications such as gameplay because it is very fun and it has a feedback loop. So basically what it does is that we were having an output right now in the previous time, like we were sending the data in and we were getting an output whether it is a cancer or spam email or not or what is the prediction for it, right? But in this what is happening is that what the output is, we are sending it as a feedback loop into the input itself. So as you can see, the agent is doing some action on the environment and then it is outputting with a reward to the agent that whether it was a good move or a bad move. So whenever we are playing a game, the award can be score. So if our score is improving, the AI is playing good. If our score is decreasing, the AI is playing bad. That kind of feedback reward function goes to the agent and it learns which is a bad move or a good move. A popular example from previous year is Google's AlphaGo playing versus the world champion Lee Sedol in the game of Go. So Go is a very ancient Chinese game in which we have to basically mark the territory and win. It is a two-player game. So the results of the game were AlphaGo won 4 times out of the 5 games and Lee Sedol won just once. So this was completely a pure application of machine learning which was thought to be not acquired for the next 10 years, but Google achieved it last year itself. So why is it such a big deal? We even play chess, right? And the chess AI have been there from 1990s. So why is it that Go is such a popular thing right now, that why AlphaGo is so popular? The reason is that in chess, basically whenever we play a move, like I move a pawn or something like that, we have a tree basically that these are the possible moves we have. So on every move, we have just 20 possible moves. Like if I move a horse, like we say in Hindi, right? So if I move a horse, what are the next possible moves that the front person can make and what are the next moves I can make? So we can make a decision tree and solve it. That was possible using brute force search as well. We can find the best optimal move by traversing the tree. But in AlphaGo, there are 200 possible moves after each move. So whenever in chess we have just 20 moves, whereas in Go game we have 200 possible moves after every game. So the number of possible moves in Go game in total is 10 to the power 170. Can anyone tell me how many atoms are there in the universe? Just a random guess. Anybody? Okay, so I will just conclude it. It is 10 to the power 80 only. In the complete universe, there are only 10 to the power 80 atoms, whereas in the one single game of Go, there are 10 to the power 170 possible moves. So you can understand the complexity of playing this game. Even the players itself sometimes say that they played the move intuitively. They didn't know why they played it, but they understood that this might be a good move and they played it. So it is a very complex game, and it is like Google won in front of the world champion, so that's a big achievement. So let's see an example of reinforcement learning that I told you. So how many of you have played this game where you have to break the bricks from the board and bouncing up the ball? Everybody would have played it, right? Okay. So let's see. So this is deep Q learning using the algorithm deep Q learning. This was also made by Google. So let's see. So watch how the algorithm is playing the game. So this is in fast forward mode. It's not playing so fast. And by playing again and again, earlier the ball just used to move, it didn't even move. But right now, if you notice, it has developed a special strategy to move the ball up the dice so that the ball stays there for a long time. So this is something which is machine learning's power, that we need not make the rules itself, but the machine learns it from itself. So it learned from the feedback loop that the score is increasing on whenever it is following the ball and making it move up. So it learned from that and it basically improved time by time, and then it scored so well. The current popular algorithm is deep learning. Deep learning is one of those algorithms which, if you are going to pursue machine learning in the future, this is something which you will be working on. So deep learning is basically how our human brain works. It is basically mimicking how the neurons in our brain work. So let's see. So the neurons basically are connected to one another, just like the human brain's neuron cells are connected to one another in a mesh. So what happens is that the input layer has the input data, and that transfers towards the output layer, which classifies, which is basically the output of whatever computations we are doing in the neural network. So this is the artificial neural network, whereas this is the human brain. So you can see the analogy that all those neurons are connected to one another, just like we have neurons in our brains. So how this actually works, let's see. So what happens is it is a feed forward and back propagation algorithm that is used in neural networks. What happens is that we give the input, such as image pixels maybe, or some kind of text or anything, and these functions, these neurons have some kind of functions in it, like addition, summation functions. So what it will do is these edges have some weights, like we are showing over here, W1, W2, W3. These weights are multiplied and added. All those edges which are coming over here, those are multiplied with their weights and added in this function. So this transfers further in the neural network. Now after the first layer has been done, now these will be the input for the next layer, and these edges will be the multiplication factor. This will again be performed over here, and finally in the output we will get the output. So the intermediate nodes, the layers are called hidden layers. This is the input layer and that's the output layer, right? So don't worry about the maths, but I just wanted to give you a gist of it, that what is happening. So, but then how, you might say that how is it learning initially, that what should be the output for it. Like for example, if I was giving the tumor size and where the tumor is as the input, how is the machine learning algorithm telling us whether it is a malignant or a benign tumor? So what it does is it uses a back propagation algorithm. As I told you, with the input data, we had some labels in it. So like input data was size, and here we had malignant. So while I am training the data, what I will do is I will feed the data, and suppose it gave me malignant. So, but actually it was benign. So what I will do is I will find the error in it, the probability which is giving. I will find the error in it, and I will rectify these edges weights, because these are the ones getting multiplied, right? So I will rectify these errors by a small bit, so that the next time whenever that input is given, it will give the right prediction. So this is done in each layer, and so it gets improved one after the other, right? Okay. So have everybody uses Facebook, right? So in Facebook, whenever we upload an image right now, it automatically tags our friends or ourselves in it, right? Everybody would have seen it. So that is one application that I did, and let me show you the demo for that. Okay. So face recognition. Okay. It's not visible over here. Just a second. Okay. So as you can see, it can classify. Right now, I trained the machine learning classifier on my image, and so whenever it sees my face, it is recognizing that alright, this is Anubhav. And so I did it with Selena Gomez as well. So let me just show you what it does. So whenever I give the image of Selena Gomez, it's also classifying that in. Okay. So it can be done with any of the images. Like if I take any of your images, file image of yours, and train it on the neural network which I made, and then it will be able to recognize you as well, similar to what Facebook does. So do you want to know how it works? Okay. So let me show you. So basically, what we see is an image, but what the machine sees is the array of pixels, the numbers basically. In computers, we have these pixels where we have some values for the image. Like for 1, we have dark pixels over here with numbers 1, 1, -1, something like that, and rest of the places we have 0. So the computer actually sees pixels. These are the pixels which goes into the input layer for our data. So what happens is that first of all, I try to find out the face in the image. So because first of all, I need to know where the face is, and after that only I will be able to predict what that face is, whose that face is. So for that, I use a technique known as hog face pattern. What it does is that this is a hog face pattern which was pre-built, and as you can see, you might realize that these are the eyes and the eyebrows in the pattern, right? So whenever we have an image, basically we make the gradients, the vectors, where the image is dark, where the image is light. We make vectors in that image, and so that helps to make such kind of a pattern in our image itself. And so we compare this hog face pattern that where it is matching with this image of ours. So wherever the image matches, we say that alright, this is the face, we have found the face, this is the location of the face. That's the first step. Okay, so once we have found this face, we have cropped the image till that face area. What we do next is to find the points on the face. So why I did is to basically improve the accuracy of the algorithm. If all the faces in my image are in the center, aligned with the eyes and the mouth, that will be easy for my algorithm to classify because all the faces will be similar. If my face is there and your face is there, those are in the center, it will be easy for it to compare, right? Because it's just seeing the numbers over there, the pixels. So it is finding, basically I used a neural network to find out these 68 facial points over on the face, and those are then aligned into the center so that our image is in the center, the eyes are over here and the face all that. So once the image is aligned, I send it to a convolutional neural network. So it might look a very big word, but don't worry about it. So just think of it like a neural network that we had, like the neurons in the brain. So the convolution neural network basically takes the input array pixels, the image pixels that I told you earlier. It takes those image inputs, pixels inside, and it outputs 128 numbers. So like in the output layer earlier we had just one node, remember? Now we have 128 nodes and all those nodes are giving us some numbers. So what it does is, it creates basically unique numbers for the similar kind of image. So like if I feed my two images, it might give me a number which is close to 5. And if I feed one of your images, it might give me a far away number that is 10. So what I can do now is to plot a graph. Like imagine it's like a graph. So if 5 is over here and 10 is over here, I can make a decision boundary between it that all the values near it will be of Anubhav and all the values from this side will be of Selena Gomez. Okay. So that is kind of the approach which happened. So I generated these encodings. So let me just show you. Okay, just a second. So these are the basically encodings that I created. So these are the 128 numbers for different images that I had. And after that, you might see that 0 and 1, some of it, and some are 2 and some are zeros in the end. So these are basically the labels. So 0 might be for Anubhav, because machine learning algorithms don't understand strings, they only understand numbers. So I just made that Anubhav is 1, Selena Gomez is 2, and so on. So the training images are inside this folder where I have some photos of Selena Gomez and all that. And I trained over it, the neural network. It created the encodings for it, and then I made the classifier, the decision boundary. I simply fed it into a support vector machine. So that classified it that alright, all these points over here are of Anubhav, these are of Selena Gomez, these are of somebody else. Let's make a decision boundary that any new image, whenever I find a new image, I will again generate those encodings for it, and I will give it to the support vector machine, and it will find out that alright, it's lying in this region, so it might be of Selena Gomez. It's lying in this region, so this is of Anubhav. So it will classify that way, right? So that's how the machine learning algorithm is used by Facebook as well to classify a new image whenever you upload it. It tries to find out in their classifier where the image lies, and then it tells you that whether you want to tag that person or not. So there are some artistic applications also of new deep learning. So like this is Deep Dream. Basically what you can see is that this is Nebula Galaxy photo on which the neural network was applied, and it can find out the faces of dogs and cats over it. So this was basically done using the deep neural network, which was trained on the images of cats and dogs. So what it did is that it gave the Nebula Galaxy image to the neural network, and it asked it that what do you see in this image? So it said that alright, I see a dog over here, I see a cat over here. So what we did is we told the neural network to make the changes in the image so that we could also see it. And so we saw that the image was transformed into dogs and cats. So why it's doing it so is that because of the weights in the neural network, those were trained to find out dogs and cats. So it will find out only those. If I would have trained it to find my face and Selena Gomez's face, so it might have found out that alright, Anubhav seems to be here somewhat in the features, so maybe put the image over there. So that's one. And another is time transfer. So basically we can make any image into a form of like artistic image made by a famous painter or something like that. And there are many applications on the App Store which you can see are based on these such things. The filters that we apply even on the Snapchat. Everybody uses Snapchat, right? So it finds out our faces and makes the tongue come out of the dog like face and all that. So that's using the deep neural networks as well. Another great application is self-driving cars. How many of you have heard of self-driving cars? Right? So initially I asked you how to make a self-driving car using A+2. Let's see how the machine learning can do 10% less. So what I did is, I'll show you. So basically, everybody has heard of Udacity? Yes, okay. So Udacity has its self-driving car nanodegree, and in that they are basically training everybody for how to make a self-driving car and all that. So recently they open sourced their simulator for a driving for a car. So what the simulator does is that it is being used by those students to basically make the self-driving car. So what I did is I used that simulator to make my own self-driving car. So let me just first run and show you how it's performing. So you can see that I am going to run the model. So this is my pre-trained model that I made. I did it on Google Cloud. I made a model mix.h file. So I am going to load this into my Python script, and I am going to run that server. So right now, if you notice that in the autonomous mode, the car is not running right now, but let the server just start for a second. So now it has started to do computations, right? So now, see, I am not driving it; it's running on its own, and as you will notice the track, when the track is turning, the car will also make its movements accordingly. So how it's doing it is using the images. Basically, imagine that on the car we have fitted some cameras. Okay, so it's taking that image input, whatever it is the car is seeing in front of it, and it is predicting what should be the steering angle so that the car stays on the road. So that's what it is doing. So as you can see, it's making the turn accordingly, right? As the road is moving, and so what I did first of all is to basically train it. And I will see, this might seem like a easy road, so I will even go with a hard one. So like, if you notice right now there is no markings of road over here on the brown spot, but it still made the turn. So it learns from my driving skills. Basically what I did is I first ran the simulator and collected the data from it, and I trained the neural network on it and how you have to move on the car. So let me just show you first the training part. So this is the training mode where we have to train the data. What I will do is I will record the session, and once I have recorded that, so what I will do is then I will make the laps. I will move the car according to my needs, wherever I want to. So I will make it learn that alright, you keep recording the data what I am doing, and it is also, the simulator is also marking what my steering angle is, how much I am moving. If you notice on the top left of the screen, there is some angle which is changing whenever I make the turns, right? So these angles are being noted by the simulator itself, which can be used later on for training. So if you see the data that I have this driving log. So what it is doing is, it is saving those images as well as the, let me show you a ton of patterns. So basically, these are the right. So this is the data which was collected after the training session, after the driving that I did. So this data is stored into a CSV file, in which I have 3 columns for the images: the left camera on the car, the right camera on the car, and the center camera on the car. And apart from that, I have the steering angle, the speed, the throttle, and the brakes. So these are the input features that I have. The images are the input features, and the steering angle, the column which is the steering angle, this is by prediction, the output. So like if you want to see the images that I have trained on, so these are like the images that were saved. If you see, these are the different images that I have which were saved on it. So this is basically my training data. So I trained my neural network on it, and after that, once my model was trained, I basically tested it out on the model itself. So this is another path which is kind of difficult to drive on because you can't see the road ahead just instantaneously. But see, even then it will be able to classify whether to turn right or left and how much to turn at what speed, even when there are shadows on it. So there is a steep turn right now. It automatically applied brakes because it knows that you can't go that much fast. So machine learning is that simple. You can make your own self-driving car sitting at your home. So I did it a week ago, and right now I'm giving a presentation on it. Okay, so you can do it too. So that is about self-driving cars. So basically, we are in a phase where the human evolution is turning towards machine. We are ourselves turning into robots, humanoids. So I would suggest that machine learning is the future.